Imagine receiving images from a distant world and discovering brilliant white patches shining against an otherwise dark landscape. At first glance, they almost look like lights placed there intentionally. For a brief moment, even experienced scientists wondered what they were seeing. Were these unusual reflections? Frozen ice? A strange mineral never observed before? Or evidence of a geological process unlike anything previously found on a dwarf planet? The mystery began with one of NASA's most ambitious deep space missions, the Dawn spacecraft. Launched in 2007, Dawn was built with an advanced ion propulsion system that allowed it to travel farther and stay in orbit around multiple destinations. Its mission focused on two ancient worlds within the asteroid belt, Vesta and Ceres. Scientists hoped these untouched bodies would preserve clues about the birth of the solar system over 4.5 billion years ago. After completing an incredibly successful exploration of Vesta, Dawn continued its journey toward an even more mysterious destination. That destination was Ceres. Discovered in 1801, Ceres has experienced an unusual scientific history. It was originally classified as a planet, later redefined as an asteroid, and eventually recognized as a dwarf planet. Today it remains the largest object in the asteroid belt between Mars and Jupiter. Although astronomers had observed Ceres through telescopes for centuries, it always appeared as little more than a blurry point of light. Everything changed when Dawn finally arrived. As the spacecraft moved closer, detailed images revealed a surprisingly complex world covered with craters, mountains and ancient scars left by countless impacts. Then researchers noticed something completely unexpected. Inside one enormous impact crater were several dazzling white regions that reflected sunlight far more intensely than the surrounding surface. Against Ceres' dark terrain, these bright patches almost appeared to glow. Naturally, scientists began asking questions. Could they be exposed water ice? Highly reflective minerals? Or perhaps an optical effect created by unusual lighting conditions? At first, nobody knew the answer. But as Dawn entered orbit and captured sharper images, one fact became clear. The bright areas were real. They weren't camera errors or visual illusions. The mystery only became more fascinating as scientists analyzed the spacecraft's data. Using specialized instruments, researchers determined that the bright material consisted largely of sodium carbonate and other salt-rich minerals. This discovery suggested something remarkable. Long ago, salty liquid from beneath the surface may have risen through fractures in the crust. When that briny water reached the airless surface of Ceres, the liquid quickly disappeared into space, leaving behind brilliant white salt deposits. In other words, those mysterious lights were not artificial. They were evidence of an active geological history. This pointed scientists toward an extraordinary possibility. Ceres may once have possessed underground reservoirs of salty liquid capable of reaching the surface through a process known as cryovolcanism. Unlike ordinary volcanoes that erupt molten rock, cryovolcanoes release icy mixtures containing water, salts and other volatile materials. Only a handful of worlds in our solar system are thought to experience this unusual activity. Finding signs of it on Ceres completely changed how scientists viewed this small dwarf planet. Instead of being a frozen, inactive rock, Ceres suddenly appeared to be far more dynamic than anyone had imagined. And as Dawn continued collecting data, even bigger surprises were waiting to be uncovered. The discovery of brilliant salt deposits was only the beginning. As scientists examined Dawn's observations in greater detail, they found additional clues suggesting that Ceres might still be changing today. Inside the famous Acator crater, researchers identified a central dome surrounded by fractures and layers of bright minerals. These features hinted that salty material had once been forced upward from deep below the surface, slowly building the unusual landscape seen today. Even more intriguing, some observations suggested that faint hazes occasionally appeared above parts of the crater before fading away. Although subtle, these changes raised an exciting possibility. Could Ceres still be releasing gases or water vapor from underground? If so, this dwarf planet might not be as inactive as scientists once believed. For decades, many small worlds in the solar system were thought to have cooled completely billions of years ago. Their interiors were assumed to be frozen and lifeless. Ceres challenged that idea. Its crust contains water-rich minerals, salts, and compounds containing ammonia, ingredients that point to a much more complex history than expected. Researchers now believe Ceres may have a layered interior, with a rocky center surrounded by ice-rich material. Deep beneath the surface, pockets of salty liquid may have survived for immense periods of time. When impacts fractured the crust, some of these underground brines may have slowly reached the surface, leaving behind the bright deposits that first captured the world's attention. This possibility has enormous scientific importance. On Earth, microscopic organisms thrive in some of the harshest environments imaginable, deep beneath glaciers, inside salty lakes, and around hydrothermal vents on the ocean floor. These discoveries have shown that life can survive under conditions once thought impossible. That raises an important question. If liquid water and the right chemical ingredients existed beneath the surface of Ceres, could simple forms of life have existed there as well? At the moment, there is no evidence that life has ever been found on Ceres. But the conditions appear far more interesting than scientists once imagined. The discovery has also changed the search for life throughout the solar system. Instead of focusing only on planets with thick atmospheres, researchers are increasingly investigating icy moons and dwarf planets that may hide underground reservoirs of liquid water. Worlds once dismissed as frozen rocks are now considered some of the most promising places to search for ancient habitable environments. Perhaps the biggest lesson from Ceres is how easily nature can surprise us. When the bright spots were first observed, some people imagined extraordinary explanations, including artificial lights or evidence of alien technology. As more data arrived, scientists reached a different conclusion. The mysterious glow came from highly reflective salt deposits created through natural geological processes. Even without an artificial origin, the discovery proved to be extraordinary. It revealed that a small dwarf planet could remain far more active than anyone expected and preserve evidence of liquid-rich processes long after its formation. When the Dawn mission ended in 2018, the spacecraft had completed one of the most successful explorations of the asteroid belt ever attempted. Although it no longer sends information back to Earth, it remains in a stable orbit around Ceres, a silent monument to one of NASA's greatest planetary missions. The data collected by Dawn continues to be analyzed today, and researchers are still uncovering new details about this remarkable world. Ceres reminds us that the greatest discoveries are not always the ones we expect. Sometimes a mysterious light turns out to be something even more valuable, not proof of alien technology, but evidence that our solar system is more active, more complex, and more fascinating than we ever imagined. And as future missions continue exploring these distant worlds, each new discovery brings humanity one step closer to understanding how planets evolve, where water can survive, and whether life might exist beyond Earth.